Hey there, this is Mr. Van. This is from lesson 1 of our first unit, which is actually the 8th unit in the geometry course of illustrative math. And this lesson's called Up to Chance. What we're going to do in this series of videos is we're going to go over the key concepts from each lesson, and I'll give you a little bit of guidance on the cool down and how to go about answering some of these questions. So let's start with key concepts. Few things are certain in life, but we can look more closely at uncertain processes called chance experiments to get a better idea of the likelihood of a particular thing happening. It's possible that there's several different results that may happen. These results are called outcomes. The collection of all possible outcomes is called the sample space. An event is a group of outcomes from the sample space. So those are 3 terms that you need to know and be able to define. So we have outcomes, collection of all possible outcomes is the sample space. A group of outcomes from the sample space is called an event. For example, flipping a coin is a chance experiment that has possible outcomes of landing with heads facing up or tails facing up. That's what we would call the sample space, heads or tails. Sometimes one outcome is more likely than another, which in the case of flipping coins, actually, you might think it's 50-50, but it's not exactly 50-50. When you do experiments and you flip a coin a whole bunch of times, depending on the coin, it might be more likely to land heads or land tails, which is where the real world starts to mess with our experimental probability, because the way that the coins are carved, one side is actually a little heavier than the other and tends to land down more often. But generally speaking, it's pretty close to 50-50. You have to run thousands. You have to flip a coin thousands of times before you even start to notice that one side or the other is a little bit more likely to happen. Sometimes an outcome is more likely to happen than another. For example, when walking outside in a thunderstorm, it's much more likely you'll get hit by a raindrop than a lightning bolt. To put a number to this likelihood is to find or estimate its probability. The probability of a chance event is a number between 0 and 1, 0 being impossible, 1 being absolutely certain to happen. The closer you are to 0, the less likely something is to happen. The closer you are to 1, the more likely it is for something to happen. And in the case of flipping a coin, since I said it's about 50-50, that's going to be almost exactly 0.5. Like I said, it might be a little bit more, a little bit less, depending on the coin in the real world, but it's going to be about 0.5. So to find probability, essentially what you're going to do is you're going to take a look at the results that you're looking for, the number of possible results that you're looking for, and taking those divided by the total number of possible results. So for example, let's say you're throwing dice with your friends. If you look at a number cube, we have numbers on it. All the possible numbers that could land up are 1, 2, 3, 4, 5, and 6. That's what we would call our sample space. Now, if we were to look at the probability of rolling a 1, well, there's only one 1 on the number cube, and there's 6 total numbers. So that's the probability of rolling a 1. Now, if asked, what's the probability of rolling an even number? Well, probability of rolling an even number. Well, how many outcomes are there in our sample space that are even? Well, we've got 2, 4, and 6. So we have 3 possible outcomes that we're looking for, divided by 6 total possible outcomes. Or you could reduce that down to 1/2 or 0.5, which means that you're just as likely to get an even number as you are to get an odd number. This is how probability works. You take the number of outcomes that you're looking for and divide by the total possible number of outcomes. So in this case, talking about getting struck by lightning, out of 700,000 people that could be struck by lightning, only one of them will actually get struck by lightning. So we have one person, one outcome that gives us the results that we're looking for, getting struck by lightning, divided by the 700,000 total people in our sample space. So let's take a look at the cooldown. What affects probability? Match the description of the events to the most likely probability for that event to happen. So probability for an event to happen. Well, how many outcomes possible are there for a particular event? And you're going to take that divided by the total possible outcomes. So number 1, for example, a short children's book is open to a random page. The probability that the page is numbered something between 1 and 10. So a short children's book. Short children's book. Okay, so a short children's book probably doesn't have that many pages for our total possible outcomes. That would go on the bottom here. Page 1 to 10. Well, there's 10 of them, right? So we'd have 10 over, maybe not a very big number. Anyway, I hope this is helpful. Try to answer all of these questions as best you can. And if you have any questions, let me know.